Hi guys, me again. This video is going to focus on the Khan Academy and specifically quiz 3. I noticed those of you guys that are doing it, this was a hard um, skill to master in Khan Academy, not necessarily because you didn't know what you're doing, but the way they were asking the questions depended a lot on understanding their the way they instructed you on how to find limits. So first thing I want to go through is this big schematic that they frame all the questions around, and specifically one whole exercise is based off of you clicking and dragging. When I try to do this without understanding it, I didn't do well. So here's my in a nutshell 15-minute video on Khan Academy. Hopefully you can do this video with me and then you'll feel more prepared to master the unit exam. So the idea here is that all these questions will start with A, direct substitution, and you're going to let the limit go to A by substituting in the value of A. And then what happens after that depends on what you get. So you kind of have to be doing this on paper and substituting in A. And what's going to happen is either you're going to get a 0 in the denominator and not in the numerator, and that would lead to answer choice B. So you direct substitute, 0 in the denominator, not the numerator, and that means that you would have an asymptote probably. That's what it means on a graph. If you directly substitute in the numerator and denominator and you don't get 0 in the denominator, then you found your limit found. And then finally, if you do direct substitution and you get this indeterminate form 0 over 0, what that actually means to you now is that you could use L'Hopital's rule. So for the questions that I'm scrolling, hopefully you can see this as I'm talking, for a question style like that, you could use L'Hopital's rule where it's just filling in the blank. But if you're wanting to get mastery and really understand limits and basically the chapter in our book, chapter 2, then there are other things that you could do before you learned about L'Hopital's rule and before you learn derivatives. And that's what these style of questions are all about. So the options are that if you do get this indeterminate form, that's what this second row of options is for. It depends on the function. So if it's a polynomial, x squared, x cubed, then you try to factor out a common factor or, two factors. If you got a lot of radicals, then you would use the conjugate, which is a term plus the opposite of the original binomial that was there. So if you have like x plus 3, the conjugate would be x minus 3. It all depends on what the function is, right? And then finally, if there's some trig there, then you would try to use an identity. And if you're following Khan Academy, the two identities that they have, which I suggest are the ones that you know, are cosine 2x, the double angle, and then the Pythagorean, which is sine squared plus cosine squared equals 1. And that's how they are. Those are the two identities that they're referring to in part G. Finally, if you do change the form, either by factoring or doing the conjugates or with trig identities, then you change it and you try to sub it in and sub in again. If you don't get 0 over 0, but you do get something over 0, that would be choice B again, that I can't find the limit, but at least now I know that there's an asymptote there. So basically this here, that schematic is going to guide you through a big chunk of what Khan Academy is testing on quiz 3. So let me pull up my Khan Academy. And I'm right now, I have different, I went up to the top right hand corner of my screen, and I have different options, right? I am a teacher, I am a parent, I am a learner, and I'm going to go in as if I was a learner like you. And this is what you should similarly see on your screen is on the left side, courses, missions. You might not have a mission, but different courses. And I'm going to go to Calculus AB. It says see all 10. Those are 10 different units. So you're not going to need to cover all the units like I said in the other video. There are 7 units that you want to be a master in. And so at the top, you do have the option of challenging the entire course, right, to see kind of where you're at. And every time you do that, you're building mastery in every unit. Now, the one that we're focusing on, or I'm focusing on in this particular one, is quiz 3. So as I scroll down, I'm hoping that quiz 1, and I not just hoping because I saw many of you guys did well on quiz 1, and then quiz 2. Again, mainly I was focusing on quiz 3 because it seemed like that was the kind of stuff that if you didn't understand the way Khan was presenting it, you would miss points even though you kind of understood what you're doing. So I'm going to skip this first chunk where it says limits by factoring by conjugates, and basically you are learning those skills in isolation. But no pun intended. I meant just that skill on that exercise. And so that wasn't a pun. Anyway, so now I'm going to go to the one that says selecting procedures. And I'm going to do these 3 skills, and hopefully I'll do well with you so I don't have to do this video again. So the first one says, what are the different kind of conclusions you can get from direct substitution? And that would either be that we know what the limit is, we get 0 over 0, or we get a numeric value over 0, which means it's an asymptote. So let's go ahead and just do this skill. Let's do it together, or you watch me do it. Okay, so what I have here is cotangent squared of x all over 1 plus root 2 sine x, and we're going to negative pi over 4. Forgive me, I'm going to go back and forth, and so I'm just writing this out. Hopefully you're doing this with me, and this is a great place for us and you to practice subbing in all of your trig at these common values, right? So we're subbing it in cotangent squared of negative pi fourths. So I'm going to stop here so you can watch me work here. Now we're going to negative pi fourths, right? So negative pi fourths right here on the unit circle. And so the cotangent, these 2 legs would be of the same value. That would be negative 1, but squared, that would just be 1, right? And then I have 1 plus. So right off the bat here, I can tell that this isn't going to be the indeterminate form because I don't have a 0 over 0. What I don't know is if the denominator is going to be 0, and that is left to be found by me finding the sign of negative pi fourth, which is negative root 2 over 2. And so that's going to be 1 over 1. These 2 roots going to make a positive 2, or sorry, regular 2. Negative 2 over 2 is negative 1. And so I will get 1 over 0. And so that means that it's not the indeterminate form, but it is most likely an asymptote. So that's what I'm going to put for my answer. The limit doesn't exist, and it's probably an asymptote. Okay, next question. When I try to sub in 8, 3 times 8 is 24. 24 subtract 15 is 9. Root of 9 is 3. 3 minus 3 is 0. I'm getting a 0 in the numerator and the denominator, which means when I directly substitute, the result is indeterminate. That's specific to 0 over 0. Then the next one, I get to practice my trig one more time. So I'm going to click back over to my camera in just a second. But right now, hopefully you're writing this down with me. Sine squared of pi thirds. So sine squared sine of pi thirds. And then I got cosine of pi thirds in my denominator. And so pi thirds is my 60-degree angle. And so I've got the 1/2 as my cosine, and then I have my root 3 over 2 as my sine. Again, give me a second here to switch over to, hopefully I'll learn how to do this more quickly. And so I'm getting 1 minus, and so the sign here, root 3 over 2 squared is just going to be 3 over 4, right? And then this is a 1/2 squared, so that's just 1/4. I'm not getting a 0. I'm kind of going quickly. I feel good about that, but basically at this point, I just have to know whether I'm going to find a limit or not. So based off my quick math there, the limit exists and we found it. All right, doing great. Finally, subbing in pi halves isn't the worst, so hopefully we can talk through this without actually writing anything down. Cosine of pi halves is 0 pi halves, right? Cosine. So the numerator is 2. Sine of pi halves times 2, which is the sine of pi, which is 0, is going to give me a 0 in the denominator. However, it's only in the denominator. It is not in the numerator, right? That's going to end up being sine of pi. So I just want to get 4 out of 4 here. So I'm going with the limit doesn't exist. It's probably an asymptote. Before I check this, cosine squared of pi halves, that's the 0. Sine of pi is also 0. Thank goodness. All right. So in that first skill, again, all it is you subbing in by direct substitution. And then the next skill is, well, what do you do after that, right? So let's run through that one more time. Or hopefully, you know, for the sake of time, so you're not watching an hour and a half of me every day, let's just go right to the last one, which seems for me at least to be the hardest one to get 4 out of 4. So away we go. Fin Yang's teacher gave him a flow chart. Here's the flow chart we started this video with. And it's got a square root, and we want to let x go to 3. As you see, if I sub in 3 into the denominator, I am going to get a 0 in the denominator. If I sub in 3 into the numerator, I will get, you see me getting my pencil ready because I feel like I'm headed towards this indeterminate form. So go ahead and write down, before we decide, write down the function you see there, f of x, and what we're going to do is we are going to multiply by the conjugate, because subbing in a 3 is going to get me the root of 1 minus 1, which is 0 in the numerator, and 3 minus 3, which is a 0 in the denominator. So for the sake of this schematic, I was calling it, we directly substituted. We got 0 over 0. There's no trig here. There's no factoring involved. It's not a polynomial. And so the next thing we are doing is we are using a conjugate. What we don't know is what's going to happen after we do multiply by the conjugate. So here's one more example here of multiplying by the conjugate. The conjugate of this is going to be the square root of 2x minus 5, but plus 1. And whatever you do to the numerator, you also have to do to the denominator. This is the difference of two squares. So if I was distributing, these two is what I would multiply first. That's just going to give me 2x minus 5. When I multiply these two terms and these two terms, those are the ones that cancel, the difference of two squares. Then I still have to multiply -1 times itself. In the denominator, it is a mess, and I'm just going to leave it a mess. So I have two terms, and it is two factors, sorry. X minus 3 is a factor, and then the square root plus 1 is the other factor. Now, this can get simplified into 2x minus 6, which in turn, I would be able to factor out a 2, and so this factor cancels. And so I'm left with a new f of x that I can sub into, and it's the square root of 2x minus 5 plus 1. The question is, now am I able to let the limit go to 3? And the question is yes. This feels familiar to me. And the numerator is 2. The denominator is going to be root 1 plus 1. And that's going to give me 2 over 2. Again, it's not asking me directly what the limit is. It's just asking me to talk through the process of what I would do. And so I tried to directly substitute. I got 0 out of 0. I multiplied by the conjugate, and then I tried direct substitution again. I was able to find the limit. So those are the 5 things that I'm trying to organize here. Direct substitution, indeterminate form, multiply by the conjugate, direct substitution once again, and the result was that the limit was found. All right, next question. What happens when I directly substitute? We'll try to do it out loud, but right away, I go to the denominator. 1 squared minus 1 is going to give me a 0. When I go to the numerator, e to the first power is e minus e is 0. And so I know it's going to be A and then D. And the question is now, what can I do? And so go ahead, if you're working through this with me, hopefully write down g of x. And what I see is a common factor of e. However, it's not the easiest thing to factor out. Let me try it. So I'll do it on paper before I cut away. So if I do factor out an e, I'm left with x and e to the x minus 1 minus 1, and that's not common to the denominator. If I factor the denominator, I'm going to get x plus 1, x minus 1. I'm not going to be able to factor out anything common. If I try to factor out e to the x, I'll get x minus e to the 1 minus x, which is also not a common factor. So I'm assuming that this one is going to be the style that what I'm going to try to do is approximate. And I think I'm just going to go for sake of time. And no, not for sake of time. Let's go ahead and let us graph this sucker. So now I'm going to go to Desmos and graph e to the x minus e. Again, on the exam, I don't think you're going to have to do this. You're not going to use a graphing calculator. So I'm just going to wing it here for the sake of your time. And I'm going to say that when we did direct substitution, it was the indeterminate form of 0 over 0. And at that point, do I have a conjugate that I can multiply by? I can multiply by x to the e to the x plus e. Let me try to do that on paper real quick, see if it helps. And so if I multiply the numerator by the conjugate, I would get x squared e to the 2x minus e squared, all over a mess. So hopefully you forgive me for getting this one wrong here. After the indeterminate form, I'm just going to go to the approximation. And then I'm going to say, I'm going to take a guess that the limit is found. And I'm going to get help. And I'm going to move on. Direct substitution, indeterminate form, approximation. And so you can't find the limit because you're just approximating. That was pretty close, huh? Come on now. Okay, get out of there. There we go. All right, next one. Hopefully, oh, not last one. All right, here we go. Teacher gave Camille a flow chart. We're subbing in negative pi fourths and cosine. If you sub in a negative pi fourths to cosine a 2x, you're going to get cosine of negative pi halves, which is a 0 in the numerator. The cosine and the sine at negative pi fourths will be opposites. If it was just pi positive pi fourths, they'd be the same. But at negative pi fourths, they're opposites. So that leads me to my indeterminate form. At this point, cosine 2x is one of the identities. But instead of me approaching this with an identity, I'm going to remind us again that we do have L'Hopital's rule. And so what I'm doing here is I'm going to use L'Hopital's rule to see if the limit exists. And then I will manipulate Con a little bit because I am not going to use a Pythagorean identity. I am just going to see if it exists. And then I will say that I use the Pythagorean identity. And so that's what I'll cut away and do right now is I'm going to use L'Hopital's rule instead. So I am looking for the limit as x goes to negative pi fourths, and I'm going to use L'Hopital's rule. And so I'm looking at the derivatives of the limit as x goes to the same place. And so the derivative of cosine 2x using the chain rule would be 2 times negative sine of 2x. The derivative of cosine x in the numerator and the denominator is negative sine x, and then the derivative of this guy is positive cosine x. And now I'm going to see if the limit exists. And so I'm going to get -2 of the sine of negative pi halves all over negative sine of negative pi fourths plus cosine of negative pi over 4. You're getting extreme practice in here, yeah? High intensity math workout. So now I'm considering two different angles, right? This is negative pi halves, this is negative pi fourths here. And the sine of negative pi halves is -1. So -2 times -1 in the numerator. And then in the denominator, I'm going to get negative the sine of negative pi fourths. So that's the opposite of negative √2 over 2. The cosine of negative pi fourths is positive √2 over 2 because that is the x value. Again, I just need to know if it exists or not. And in this form, it does appear as the limit exists. And so let us see if that will move me forward on this scale here. It's trig, so I'm going to be able to use an identity with cosine 2x. What I did was use L'Hopital's rule to establish that it did, the limit does exist. So direct substitution found me that it was the indeterminate form. I didn't use trig identities, but I'm pretending that I did. And after I used trig identities, I tried direct substitution again, and the result was that the limit was found. All right, last question, ladies and gentlemen. Happy Friday. That was the last question. Hopefully it helps you out a little bit and you're able to level up and master limits and continuity. Again, good luck. I was going to come back on to do the squeeze theorem maybe later tonight or tomorrow morning. You have a good rest of your night, and please email any questions that you have.